This is the last video in the series of videos on 8D problem solving. If you still have any doubts and want me to upload a video on any specific topic, please feel free to mention it in the comment box. In this video, I will cover D5, D6, D7 and D8. So, let's look at these steps in the upcoming slides. D5 step is to choose permanent corrective actions. Once the root cause related to occurrence, detection, and system is analyzed, next step is to take actions on it to get rid of the root causes analyzed to prevent recurrence of the problem. And since these actions are to completely get rid of the problem, are called as permanent corrective action, that is, PCA. And as the name states, these actions should become permanent unless there is a change required in future. Prior to deciding the possible actions as PCA, consider aspects such as feasibility, that is practicability of the solution. Consider actions that would be realistic, practical. Consider the cost of the solution being selected as PCA. Since PCA is nothing but permanent actions, consider solutions that will be robust so that it can perform effectively for long term. Also consider the maintenance required of the PCA being selected. For example, a sensor is being added as PCA. Consider whether it can be maintained properly during the lifetime of the product. Further, let's try to understand PCA by continuing the same example as used in the root cause analysis section, that is D4 step. The problem that we analyzed was vehicle model X ran 7800 km, had an accident, that is, hit on tree at 7 p.m. on 10th October 2021. Driver got an injury on head, got 10 stitches. No one else was injured, although two other passengers were sitting on the back seat. The root cause we found was there was no learning earlier, hence the design wasn't having any provision to cover joints to prevent accumulation of dust. Hence joints of the brake mechanism were open where dust got accumulated. This resulted in it getting jammed. Therefore the brakes failed, causing the accident. If you haven't seen the root cause analysis video, I am giving link in the I button above. It is one of the most important steps. Once the root cause is identified, we will need to determine the solutions that are possible to get rid of the root cause permanently. If we look at the root cause properly, we will find two causes, which are there was no learning earlier, and the design wasn't having any provision to cover joints to prevent accumulation of dust. Hence, we will need to take action to eliminate both of these causes. For there was no learning earlier cause, we can take an action such as a learnings database will be maintained that is derived from customer complaints and test results. This will help identify problems early and to take actions on it before it resulting into such bigger problems. This learnings database will be updated and be reviewed minimum on fortnightly basis by the continuous improvement team, and actions will be initiated accordingly. Please note, such actions depends based on the process and domain experience. Hence, always use cross-functional team to get better solutions. And for the cause of the design wasn't having any provision to cover joints to prevent accumulation of dust, the action can be like brake design will be modified to prevent accumulation of dust between joints. D6, that is implement and validate corrective actions. We are following all these steps so that the problem can be solved permanently to prevent recurrence in future. However, we need some mechanism to check whether the solutions implemented are really effective in solving the problem. Hence, once the PCA is implemented, we will check its effectiveness. Such effectiveness verification includes validation. That is to check whether solution works effectively based on trials. It might include producing few pieces. Another type of effectiveness verification can be short-term, such as 1 day's production or production of one batch. Third type of effectiveness verification can be for little long-term, which can be around 1 week's production time, to check whether any defects still occur. Such period for effectiveness verification is determined based on the problem, product, and process knowledge. If any defect still occurs due to the same cause, we can consider the solution, that is, PCA, is ineffective. And we will need to review the PCA and choose a better solution. Once the solution, that is PCA, is found effective, we can move to next step, that is D7, take preventive measures. Once the solution is found effective, we need to ensure the PCA really becomes permanent by installing it in the system. We do not want to depend on single person or only certain number of people to be aware of the solution. Whoever influences and can influence the solution should be able to get the information regarding what needs to be followed for sustaining it. This removes the ambiguity. One temporary action is to deliver training regarding the solution being implemented. However, training only helps on temporary basis, since we don't know who else will handle the machine, line, or even the plant in future. These new people will be unaware of problems occurred earlier and the actions that needs to be followed to prevent its recurrence. Hence, we need other actions to help in such a case. Such actions include, but not limited to, document reviews. Please note, I am mentioning document reviews here, not document revision. By document review, it means checking whether the document needs to be revised. If there is a need to revise the document, then it must be revised. But you'll need to maintain evidence of such document review, whether or not revised. And will also need to maintain record of justification, in case the document is not revised. Such document reviews include, but not limited to, FMEA, that is, failure modes and effects analysis. The problem that is being solved should be incorporated in the failure modes, if not already present. And the permanent corrective actions taken against the detection and occurrence root causes both should be added in the FMEA. Another document that needs to be reviewed is Control Plan. Control Plan is nothing but an extension of FMEA. This document specifies the controls, that is, actions to be followed on the shop floor. Instructions, such as work instructions, will need to be reviewed in case certain work steps are revised or certain precautions needs to be taken. This can be a subset of controls specified in the control plan. User manual, procedures, formats or checklists. In some cases, we might need to review the training manual, in case the PCA seems difficult to easily understand or lots of steps are involved in the action's implementation. Such revised training manual will help in training new employees on the PCA. Learnings database. The learnings from the problem solving needs to be updated in a central database so that other personnel can refer to it and learn based on it. Such database can be used as a reference while developing new products, processes, hence gives an advantage to implement those learnings early to prevent similar problems in future. Machine history cards, maintenance plans. We might replace or add components of a machine, fixture or tools during problem solving. Such changes needs to be incorporated in the history cards so that the concerned personnel can be aware of such changes. And it also helps to track down in case any problem occur in future. In addition to making changes, we might need to review the maintenance frequency under PCA if planned. Additionally, we need to review whether the solution we implemented as PCA needs any maintenance. If required, we will need to make a maintenance plan for the same. We might also need to review drawings, whether of part, fixture, tool or even machine, wherever applicable. Assume a similar problem occurs in future on similar product or process. What would you do in such a case? Would you follow 8D again for that problem? Won't it be a repetitive work if the product or process is similar? Hence, the better option would be to implement solutions of one problem solving, that is PCA, from one problem to another. This is called as horizontal deployment. Under this step, we need to consider whether similar products or processes are present where similar problem can occur. If present, we need to implement the same solutions there to prevent problem from occurring there. This saves a lot of stress and time in future. Hence, I suggest spend sufficient time and care in horizontal deployment. As covered in the earlier steps, problem solving requires a lot of effort, that too a team effort. Hence, a commitment is required in the problem solving. Therefore, the last step in the problem solving, that is D8, is congratulating the team. Take time to congratulate the team for successfully solving the problem and to appreciate the efforts taken by them, so that similar commitment can be there in future problem solvings. Thank you so much for watching this video. If you like the content, please like, subscribe and hit the bell icon to get regular updates.